Welcome back to the channel. So now we are going towards our next step, which is understanding the chapter 1. We'll move forward with step-by-step process. We'll understand each concept which is given in this chapter. So the first thing is the chapter name called The Promise and Perils of Distributed System. The first thing and most important thing that we need to understand is the limit of a single server. What are the limits when we use just one single server, and why do we need to come up with this come up with a concept called distributed systems? What are the overall need for this? So in this book, we will discuss more towards distributed system, right? But what exactly do you mean when we say distributed system? And why is distribution necessary? Why should somebody just always use distributed system and not having just one single server? Why this actually came into picture? Let's start from the very basic. So in today's digital world, the majority of our activities rely on network systems where whether it's ordering food or managing finance, these services run on a server located somewhere else. For example, we always use Zepto, Swiggy, Zomato for ordering our food or groceries. So somewhere in the servers they must have been stored. The server is running somewhere which is allowing us to do all the like transactions that we are doing right now in those applications. So when we are using some cloud services like AWS, GCP or Azure, these servers are managed by the respective cloud providers. So we have very popular cloud providers like AWS, GCP and Azure. There are so many, but these three are very popular. So they do manage our servers. They make sure that our servers are always up and running. They make sure that like we have different types of services in that. So based on that, they care about our servers, our services. They based on that they give the flexibility to us to manage either by us or them. We can do all these things. So they store the data, they process user requests and perform computations using the CPU, memory, network and disks. So basically these are the four fundamental physical resources that are very essential for any computations, and these are the actual things that are doing all the job in the server called, again I'm repeating, CPU, memory, network and disk. This is the most important four things that we have to understand. Consider a typical retail application functioning on a network system where users can perform actions such as adding an item to their shopping cart, making purchases, viewing orders, or querying either past orders, whatever they have ordered before. The capacity of a single server to handle user requests is ultimately determined by the limitations of four key resources like network bandwidth, disk, CPU, and memory. So, as I said before, these are the four things that are the actual ultimate goal of our system to keep things up and running. So, they determine what are the limitations that we have in the system. So the network bandwidth sets the maximum data transfer capacity over the network at a given time. So how much data, how many packets of data you can transfer over the network in certain time is defined by the network bandwidth. So we have to always make sure that our request and our calls are below the network bandwidth to have a smooth user experience. For example, with a network bandwidth of 1 Gbps, which is 125 MB per second. No, this will be like 1000 MB per second. I think this is some misprint or something. Okay. Anyway, and 1 KB record being written on read. So let's suppose you have a network bandwidth of 1 GB per second, and 1 KB record is being written on every read, either written or read. A 1 KB data is getting transferred throughout the network. Okay, so by the calculation we can handle 1000, not 1000, sorry, 1,25,000 requests per second. However, if the record size increases by 5 MB or 5 KB, the numbers of requests that can be passed over the network will decrease, right? That's totally making sense, because let's suppose previously we had 1 KB record which are being written or read. Now we have 5 KB record which is being written and read. So we can't handle similar amount of request by just having if we increase the record size. We have to increase our network bandwidth as well. So the number of requests that can now passed over the network decreases to 25,000. Correct, right? So again, like the disk performance, it also depends on several factors, including the type of read that we are doing, or even the write operations that we are doing, and how well our disk is architected to handle caching and all those things. Mechanical disks are also affected by hardware features such as their speed, clock speed. You know, whenever you go buy a computer, you always ask for what is the clock speed of this system. So those things like determine how fast you can run multiple things in the system, and the seek time, etc. Sequential operations usually have better performance than random ones. Moreover, the performance is influenced by concurrent read and write operations and software-based transactional processes. These factors can significantly affect the overall throughput and latency on a system server, on a single server. So for example, let's suppose we have a user over here, we have a network, and this is a server, right? So inside the server we have CPU, memory, and storage. Network is outside of the server, and user always requests to the network first. So this is like resource of computations. Likewise, the CPU or memory limit is reached. When the CPU or memory limit is reached, requests should must wait for their turn to be processed. So when these physical limits are pushed to their capacity, the result is queuing. So you might have gone through queue data structure, right? So for example, when you have multiple things like async processes which are going to happen one after other, then you have to wait for the first two operations to finish before doing the third operation. So we have to like make sure that we are in the same line, and we are like keeping the order as it is. So for that we have to use the queues, so that like we can have those things. So as the more requests pile up, waiting time increases, negatively impacting the server ability to efficiently handle user requests. That's totally correct, because if you have like a lot of, as the numbers of users are increasing, your throughput will definitely going to decrease if you not increase the number of servers, or you want distribute your users to multiple different servers. That's very common, because like the throughput is fixed, like the maximum limit that your server can handle is fixed, but the numbers of users are increasing. Then you have to like make sure that you like equally distribute them to some other things, so that we can manage them. We'll go through them in depth later. But yeah, drop in throughput will definitely happen if we increase the request and will not increase the number of server, or even in the same server we are not increasing the CPU, memory, storage, and network bandwidth. So the impact of reaching the limits of these resources become evident in the overall throughput of the system, as illustrated in figure 1.2, right? So this poses a problem for our end user, that they will have to wait for their time to come. Then those processes will get served, which is very bad user experience. As the system is expected to accommodate an increasing user base, its performance actually degrades, right? To ensure the requests are served efficiently, you have to divide the process them on multiple servers. So as I told, right, you have to like, if the number of users are increasing, the one server has their own limitations. So one server will have the limited amount of capacity that it can handle. But if your users are increasing, that one server is not going to take care of everything. You have to increase the server, you have to increase the CPU limit, memory limit, all these things. This enables the utilization of separate CPU, networks, memory, disk to user handle request. In our example, the workload should be divided so that each servers handle approximately 500 requests. Correct? So this is all about why do we need to have multiple servers if our user base is increasing, if the request coming into our server is increasing. We have to because the limitations depends on these four key factors: network bandwidth, disk, CPU, and memory. So we have to also take care of them. Like we have to increase the network bandwidth, we have to increase the disk size, CPU, memory size, and all these things. either increase them or increase the number of servers and distribute them equally. The users, like the requests that are coming, distribute them into multiple servers so that we can handle them efficiently without disappointing the request or the users. So that was all for the first thing. In the next chapter, we'll understand about separate business logic